In this video, I'll be going through the 2025 specimen paper for H2 Math, paper 1. Okay, so let's go through question 1. So I've provided a link in the description below for the question paper. So do download it and refer to it while we go through the worked solutions for the questions in paper 1. So let's start off with the first question. So in the first question, it is a rate of change question. So let's take a look at what are we given in this question. So we are given that we have a circular inbob is expanding such that the rate of change of its diameter d with respect to time is 0.3 cm per second. So let's write out this. So we are given dd dt, so this uppercase d is the diameter, is 0.3 cm per second. Okay, so what are we asked for? We are asked to find what is the rate of change of the circumference and the rate of change of area with time when the radius is 2 cm. So for this question here, they have only defined uppercase d, which is diameter, and t, which is time. So we first need to define two other variables. So let's say let c be circumference and a be area of ink bolt. Alright, so now that we have defined C, uppercase C and uppercase A, we can start to use them for the rest of the questions. So what do we want? So the question, we need to find dc dt and dA dt when radius equals to 2 cm. Okay, so let's start off by doing finding dc dt. So we are given the d dt and we want to find dc dt, so we know that we need to make use of chain rule, right? Okay, so in order to make use of chain rule to find the related rate of change, we first need an equation between c and d. So since c is the circumference, we can write that c is equals to pi d. Okay, so circumference is pi times diameter. So next we need to differentiate this. So dc dd is equals to pi. So once we have found dc dd, we can find dc dt by using chain rule, which is equals to dc dd dt. Right? So dc dd is pi and dd dt is given is 0.3. So in other words, this is equals to 0.3 pi cm per second. Okay, so we have found this. Next, let's move on to find dA dt. So to find dA dt, again, we need an equation between A and D or A and C because we have already found dc dt. But it's easier to form an equation between area and diameter because area is equals to pi r square of pi d over 2 square. Okay, which is equals to 1/4 pi d square. Next, let's differentiate this. So we have dA dd is equals to half pi d. Okay, now that we have found dA dd, we can find dA dt by using the chain rule. So dA dt equals to dA dd times dd dt. So dA dd is half pi d. dd dt is given is 0.3. Okay, and they gave us radius is 2 cm, right? So if they give us radius is 2 cm, this means that we cannot leave our answers in terms of d. We need to substitute in the value, okay, because we are interested in the rate of change when the radius is 2 cm, or in other words, when the diameter is 4 cm. So maybe I can write here diameter, or actually I don't need to spell it out because d has already been defined in the question. So I simply just write uppercase d equals to 4 cm. So when d equals to 4, I have 0.6 pi cm squared per second. Okay, so this is the answer for the A dt. So you notice this question here is very A math, right? So typically for A levels, the first question is going to be an easy one. Okay, you should be scoring. Okay, so with that, let's move on to the next question, question 2. Now let's move on to question 2. So in question 2, okay, you are given a curve with equation y equals to x cubed is transformed onto the curve with equation y equals to fx by a translation of 2 units in the negative x direction, followed by a stretch factor of 1/4 parallel to the y-axis. So you're asked to write down the equation of the new curve. Okay, so let's do it this way. Okay, so you just need to write down, right? So we know that this curve is transformed, okay, by first a translation in the negative x direction. So if this is y equals to gx, after the first translation of 2 units in the negative x direction, it will become y equals to gx plus 2. Next, you have a stretch, okay, and scale factor 1/4 and is parallel to the y-axis. So after this stretch, it will give us 1/4 gx plus 2. Since gx is x cubed, so the new equation is y equals to 1/4 x plus 2 cubed. Okay, so let's write in the answer here. Don't need any working because they ask you to write down, so just write down. Now that we have done this, let's move on to the next part of the question. So you are asked to sketch C and the curve y equals to fx. So y equals to fx is basically y equals to 1/4 x plus 2 cubed. Okay, on the same diagram. So I need the same diagram. Next, I need to state the coordinates of the point where they cross the x and y axis. Okay, so this I will label it 1, coordinates, okay, of the x and y intercept. Then next, I'm also asked the coordinates of the points where the two curves intersect. So just x coordinates, so you don't need to give the y coordinates. Okay, so it's the intersection number 2. Okay, then give your answer to 3DP. So this is a very clear indication that you can do the whole question with your GC. So just type in the two equations, y equals to x cubed and y equals to 1/4 x plus 2 cubed. Then use the calculator to find the x-intercept, the y-intercepts. Okay, or you can just find it yourself. It's pretty straightforward. You know that y equals to x cubed. The x and the y-intercept are both 0, 0, the origin. Because when x is 0, y equals to 0. Then by looking at this equation, you also know that, okay, the x-intercepts occurs at x equals to -2. So when x is -2, y is 0. And when when x is 0, y is 2. Okay, or you can just use your GC to find them. Then next, use your GC to find the x-coordinate of the point where the two curves intersect. Just simply go to Cal, okay, on your calculator and look for intersection and find the intersection between the two graphs. And in that way, you'll be able to find the point of intersection. Okay, so use your GC. This word here is a very clear indication. Use your GC. Okay, so let's put in the things that we have found from the GC. So let's first write, okay, y equals to x cubed. So we know that the x and y intercepts occur at 0, 0. So for y equals to, 1/4 x plus 2 cubed, the x-intercept occurs at -2, 0, and the y-intercept occurs at 0, 2. Okay, so you need to put this inside your graph. All right, so basically, let's sketch. So this is what I get from my GC. Okay, I'm going to sketch it roughly here, but in the work solution, which you can download in the link below. So let me put that in. So this is the y equals to x cubed. Okay, this is y equals to x cubed. Okay, and I put in 0, 0, which is the x and y intercept. Then let me use another color, maybe red. Okay. Okay, then for this one here, I have minus 2, 0 as the x-intercept. And then I have 2, 0 here. Sorry, 0, 2 as the intercept. And then from the GC, I also found that the two of them intersect at around 3.404 when rounded off to 3 dp. Okay, so now let me sketch this. So it looks something like this. Not too good. Let me redo it. Okay, this is the point of inflection, all right? Okay, and then this curve here is y equals to 1/4 x plus 2 cubed. Okay, then I need to put in what the question asks for. Okay, by GC, x coordinate of point of intersection is 3.404 when corrected to 3 decimal place. Okay, so this is a very GC question. Right, so now that we have done with question 2, let's move on to question 3. So go on to question 3 now. What's question 3? You're asked to sketch this curve, giving the exact coordinates of the points where the curve crosses the axis and the equations of any asymptotes. So for the GC, we are able to find x-intercept, y-intercepts, the shape of the curve, points of intersection, but there's only just one curve here, so there's no intersection with another curve. So don't need. But we are not able to find the asymptotes. So what we need to be able to get from here is the asymptotes. So by looking at this graph, okay, we know that there are two asymptotes, right? So whenever you have a graph of the form y equals to ax plus b, okay, plus c over dx plus e, then we know that we have an oblique asymptote that occurs at here. We know that we have a vertical asymptote. Okay, a vertical asymptote exists when you have values of x which the graph cannot take, and we know that we cannot have a denominator equals to 0, so we cannot have dx plus e equals to 0, so therefore this forms a vertical asymptote. So we write it is basically x equals to negative e over d. Alright, so we are going to draw out a curve with an oblique asymptote y equals to ax plus b and a vertical asymptote x equals to minus e over d, because our GC is unable to give us asymptotes, so you do need to know the asymptotes by heart. Okay, so let's do it. So y equals to x minus 12 over x. Okay, and we have found the asymptotes, right? Or we know the asymptotes. So the asymptotes is basically this is the oblique asymptote. So oblique asymptote is y equals to x. Then the vertical asymptote occurs when the denominator of this fraction is equal to 0. So in this case, x is 0. Okay, so now that we have done this, we can actually use the GC to find the rest. Okay, So let me draw it out. So based on the GC, this is what I have. This is my X, this is my Y, and I'm going to draw a Y equals to X line here. Okay, so this is my Y equals to X. I also have a vertical asymptote X equals to 0. Okay, and this is how the curve looks like. Okay, and the other portion is here. Okay, so and then let me label the graph Y equals to X minus 12 over X. Okay, again, I have shown the entire curve in the work solution. To refer to the answer key that I've provided, okay, in the description below. Back to here, right? In the question, they want the exact coordinates of the points, okay, where the curve crosses the axis. So they want exact, so that means we can't use GC. Okay, when X is 0, can it possible? Not possible, right? Because denominator cannot be 0. No y-intercept. Y-intercept occurs at X equal to 0. So no y-intercept. So your graph also clearly shows this. So next, when y equals to 0, we want to find x-intercept, right? Okay, 0 equals to x minus 12 over x. So x squared is equals to 12. X is equal to plus minus square root 12. And we know that 12 can be rewritten as square root 4 times square root 3. And square root 4 is basically 2. So we know that the x coordinates are basically here, this point here. It's 2 square root 3, 0, and this point here is negative 2 square root 3, 0. Okay, so we have drawn this curve here. Okay, next, let's move on to the next part. So in the next part, you are asked to solve for this. X minus 12 over X is lesser than 1. So hence or otherwise. So in other words, you can draw a curve and then you can solve and so on. So let's do it both ways. So I'll do both ways for you here. So we can make use of the graph because you have drawn a graph, right? So the hence means makes use of the graph. Okay, so if I want to make use of the graph to solve this part B, right? So I want to solve x minus 12 over x is lesser than 1. So I will also sketch y equals to 1. Sketch y equals to 1. I'm going to sketch y equals to 1 here. Maybe I'll use another color, green. Okay, so y equals to 1 should be roughly here. Okay, this one is y equals to 1. Okay, so now, in order for the graph x minus 12 over x to be lesser than 1, where does it occur? So this portion here, right? Here. As well as this portion here, right? Okay. And this portion here occurs at this portion of the x value. That means x is lesser than this value here. We need to find it. And also, this part of the graph is lower than y equals to 1. So this portion from 0 all the way to here satisfies this inequality. Okay, right. Okay, so what I need to do first is I need to find this value here as well as this value here. So to find point of intersection, I'll equate these two together. So let me change it back to black. So 1 equals to x minus 12 over x. So I have x squared minus 12 minus x equals to 0. Something like this, right? Okay. So solving for it, I have x plus 3, x minus 4 equals to 0, x equals to minus 3 or 4. Okay. So therefore, I know that here is minus 3. Let me put it in red. This point here is minus 3 and this point is 4. So based on this, so from graph, okay, so we know that we have x is lesser than minus 3 or x is in between 0 and 4, right? because here is minus 3. So we know that, oh sorry, here is minus 3. Not this. So here's minus 3. So the inequality is satisfied for any portion where x is lesser than minus 3 and when x is in between 0 and 4. Okay, so this is how we solved it graphically. We can also solve it otherwise. That means just solving your normal inequalities. So you have x minus 12 over x is lesser than 1, minus 12 minus 1 less than 0, x squared. Then you have minus x minus 12 over x is lesser than 0. Now put the numerator and the denominator in, factorize them. Denominator, there's nothing to factorize, so let's just factorize the numerator. Okay, so now let's draw out the number line. So we have minus 3, 0, and 4. And because the denominator is x, and x cannot be 0, if not everything is undefined, I first put a white circle. So although for this case, because we are looking at lesser than, it's not lesser than or equals to or more than or equals to, we'll get the answer, okay? Because we are not going to include the minus 3, the 0, or the 4. But I always put in the white circle, or I recommend my students to always put in the white circle here to make sure that you will be not including it. Okay. Alright, now coming back to this, so I know that if I have to sub in a value greater than 4, maybe like 10, I'll get a positive value. So basically this will be plus, it will be minus, here will be plus, here will be minus. Okay. So now I'm interested in lesser than 0. So it will be, let me use this, lesser than minus 3 and in between 0 and 4, because lesser than 0 means negative, right? So the answer will be x is lesser than minus 3 or x is in between 0 and 4. Okay, so both methods will give you the answer because you're allowed to do by graphical method, which is the hands, or otherwise, which is how you normally solve an inequality. Alright, now that we have done with question 3, let's move on to question 4. So a student drops a ball vertically onto a hard surface and measures the height reached by the ball after each successive bounce. Okay, then she draws the ball from initial height of this, then estimates the height the ball reaches after each bounce is 7 over 8 of the height reached by the previous bounce. So this is an APGP question, right? So we know that this is APGP, and when you look at the 7 over 8 of the height reached by the previous bounce, is basically just a GP question. Okay. So you're asked to find the total distance that the ball traveled when you reach the highest point after the third bounce. So before we do this, right, for this type of GP questions, it's good to sketch out what's happening. Okay, so let's do it. So 160 cm. So I know that it initially starts from here and it is 160 cm above the ground, right? Okay, so now that I know it's 160 cm over the ground, then next it will bounce. Okay, after each bounce is 7 over 8 of the previous height reached. So after bounce 1, so here it is bounce 1, let me call it bounce 1. So it will go up again and then it will come down, right? And this is 7 over 8 times 160 cm. Then next, once it reach here, it is the second bounce. It is at the same point, okay? But I draw it horizontally so that you can see it, okay? It's easier to visualize. So this is actually still at the same place. So it goes here, then comes up, then comes down. But I'm going to write this here. Okay, so now at bounce 2, it will be 7 over 8 of this. So in other words, it's 7 over 8 times 7 over 8 times 160. So it's basically 7 over 8 squared times 160. Then it's going to go up here and down again, right? Okay, so basically this is what's happening. So what did they ask us to do? So find the total distance that the ball has traveled when it's reached the highest point after the third bounce. Reach the highest point after the third bounce. So this is the second bounce. Now is the third bounce, bounce 3. So I want to find, okay, then this distance here, okay, will be 7 over 8 of this. So it's 7 over 8 cube times 160. So the question in 4a asks us to find the total distance traveled, okay, when it reaches the highest point after the third bounce. So basically, we are going to find this distance plus this distance plus this distance plus this distance here. So the required distance is equals to 160 plus 2 times 7 over 8 times 160 plus 7 over 8 square times 160 plus 7 over 8 cube. Oh, don't need. Then the last one, you just need to go to the highest point, right? So it's not in, you don't need to times 2. It's not going up and coming down. It's just going up. Okay, so plus 7 over 8 cube times 160. Okay, then it's the GC's job. Okay, so 923 over 16 cm. Okay, done. Now let's move on to B. The ball is considered to have stopped bouncing when a bounce first results in the height of the ball being lesser than 0.01 cm. So that means it will stop bouncing when the height the ball reaches is lesser than 0.01 cm. So find how many bounces it has made. Okay, and the total distance the ball has traveled in this case. Height the ball reaches being less. Okay. Okay, so in other words, right, I know that once this height here, so it will continue, right, until bounce n. Okay, it is going to be 7 over 8 to the power. So if it's the third bounce, is 7 over 8 cube. Second bounce is 7 over 8 square times 160. So nth bounce would be this. Okay, so I know that when this is lesser than 0.1, it is considered to have stopped bouncing, right? Okay, so 7 over 8 nth to the power of 160 is lesser than 0.1. So you can use your GC to find what n is, okay? Or you can just solve it manually, okay? So both ways are right. So if I were to solve it manually, this is what I'll do. Goes to 7 over 8 to the power of n. So to find n, I'll ln both sides. But remember, I have ln 7 over 8 here, lesser than ln 0.1 over 160. Ln of a number that is lesser than 1 is negative. So if you have to divide both sides by a negative number, you need to switch the sign of the inequality sign, so it becomes greater now. Okay, so this is around 72.494 if I round it off to 2 dp. Okay, so when it is at the 73rd bounce here, on the 73rd bounce, it will be lesser than 0.1 meter, so we 0.1 cm, sorry. So we consider that it stopped bouncing, right? Okay, so the 73rd bounce is stopped. We consider that it stopped bouncing at the 73rd bounce. So it stopped bouncing at the 73rd bounce, right? Now, since it stopped bouncing at the 73rd bounce, so it has made 72 bounces. So let's write it. It has made 72 bounces before it stopped bouncing. All right. Okay, so now with that, we are asked, what are we asked? How many bounces the ball has made and the total distance the ball has traveled in this case. So we need to find what is the total distance traveled from up all the way up to the 72nd bounce, right? Because we consider the 73rd bounce to have stopped. So we need to calculate how much it has traveled here. Okay, so anything that is considered more than 0.1 meter, we still count it, right? So basically, we know that the total distance traveled, okay, will be the first time it is basically just 160 cm. Then after that, from the first bounce all the way to the 72th bounce, we need to times 2 because it's going up and coming down. Okay, so we will need to take 160 plus 2 times 7 over 8 times 160 plus 7 over 8 square plus 160 plus all the way to the 72th bounce times 160. And this is a GP. So if you just look at what is inside the bracket, it is a GP with the first term, A, 7 over 8 times 160. The common ratio is 7 over 8. The nth is 72. So it's basically 160 plus, remember to find sum of n terms of a GP is A, 1 minus r to the power of n, 1 minus r. Okay, so it is, I need to put the 2 here. Then the first term is 7 over 8 times 160. Then bracket 1 minus 7 over 8 to the power of 72 over 1 minus 7 over 8. Okay, they didn't ask for exact value. If you have 7 over 8 to the power of 72, it will never be an exact value. Okay, so just type it into the calculator and get the value. 2399.85. So let me put in 2399.85, which is basically 2,400 meters when corrected to 3 significant figures. So the distance required is 2,400 meters. Okay, moving on to question 5. The curve C has an equation y equals to 1 over x ln x cubed, where x is greater than 1. Find the exact x coordinate x equals to x1 of the turning point on C and determine its nature. Alright, so now in order to find the turning point, we need to find dy dx. So we need to find the x coordinate of the turning point, okay, and determine its nature. So we will first need to find what is dy dx and then equate it to 0 and find x, and that x value is the x1. Okay, so let's do it. So dy dx, so to find dy dx, because there are two groups of terms multiplied together and they are all functions of x, so we can either use product rule or quotient rule. Okay, so let's do it. So I'm going to use product rule. So to use product rule, I'll first keep this, my ln x cubed, and then differentiate 1 over x, which gives me negative 1 over x squared. Next, I will copy 1 over x, and then I'll differentiate ln x whole thing to the power of 3. So I'll bring down the power minus 1, and then differentiate ln x, which gives me 1 over x. So I'll get negative 1 over x squared ln x cubed plus 1 over x squared 3 ln x squared, right? So let me factorize it. So I factorize 1 over x squared out as well as ln x squared out, and I'll be left with negative ln x plus 3. Okay, so when dy dx is equals to 0, okay, I have 1 over x squared ln x squared and minus ln x plus 3 equals to 0. But I know that 1 over x squared cannot be 0 because it doesn't happen. So when x is 0, the entire thing is undefined. So 1 over x squared can never be 0. So I know that 1 over x squared cannot be 0. Ln x, so ln x by itself will always be greater than 0. So recall the curve of ln x, it looks something like that. Since ln x is always, so for ln x, okay, okay, so I'll have ln x okay, so I'll be left with ln x squared equals to 0 or negative ln x plus 3 equals to 0. So if ln x squared is 0, ln x is 0, right? So when x is 0, that means x is e to the power of 0, which is 1. And I will reject because based on the question, I am told that x is greater than 1. So it does not include 1. Okay, since x is greater than 1. Next, let's solve for this. So I have ln x is equals to 3x is equals to e cubed, and e cubed is more than 1. So therefore, x1 is equals to e cubed. Right. So now that I have done this, the next thing I want to do is to find the nature of this turning point. So there are two ways. You can differentiate it again, or you can basically use the table. It's quite complicated to differentiate it again because there are 3 groups. Okay, product rule usually just do 2. So of course you can multiply it in, but it's too tedious. So what I'm going to do, I'm basically going to use the table method. So let's look at x value, dy dx, and the shape. Okay, and from there we will determine what is the nature. So here's e cubed. So when x is equals to e cubed, dy dx is 0. Okay, when it is slightly lesser than e cubed and when it's slightly more than e cubed, there are a few ways to do it. You can basically just set a value that is slightly lesser than e cubed, okay, and determine what is your dy dx. And if you have to do so, you will get a value which is positive. And if you set a value that's slightly more than e cubed, okay, into dy dx, okay, you will get a negative value. Okay, so if you look at this shape here, it's a maximum point. So therefore, the nature is a maximum point. Okay, so let's go back. Have you answered everything that we need? Find the exact x coordinate of the turning point on C and determine its nature. So we have found the x coordinate of the turning point. Okay. So we have found this here. And we know that it's maximum point. So yes, we have answered this question. Okay, let's move on to part B using calculus. That means don't use your graphic calculator to do this. Find the exact area of the region between C and the line y equals to 0 and the lines with equation x equals to e and x equals to x1. Okay, so if you have to do this, they say don't using calculus. That means you just need to integrate, okay, by yourself. Okay, but you can still use your GC to sketch out the curve. Okay, so let's do a quick sketch on this curve. Okay, because it's easier to visualize it if you know what you are sketching, right? Okay, so from the GC, we know that the curve looks roughly like this. So let me sketch it out. Okay, so it looks something like this. I couldn't really see the maximum point, but based on the shape, it should look something like this. Okay, and we know that this is when x is equals to 1, right? When x is 1, ln x is 0. So if you actually sub in x equals to 1 here, this is 0. So your y is 0. So this one is 1. Then in the previous part, we have already found this is e cubed, right? The area, okay, between C, the line y equals to 0, y equals to 0 is basically the x-axis. Okay, some more. And the lines with x equals to e and x1. Oh, e. Okay, so it's from here, e, probably somewhere around here. And then e cubed. Okay, so what I'm going to do is I want to find required area is equals to integrate from e to e cubed. What's the equation? 1 over x ln x cubed 1 over x ln x cubed dx. If you're to look at that, you're basically integrating f prime x, fx to the power of n, and the n here is equals to 3. Okay, so to do such an integration, it will be fx to the power of n plus 1 over n plus 1 plus c. Right, so it will be ln x to the power of 4 over 4. Then I'll sub in from e to e cubed. Right, okay, so basically let's just sub in everything. You should be getting 20 units square. Okay, because after you sub in ln e cubed to the power of 4 over 4 minus ln e to the power of 4 over 4, this as the answer.
If you like this video, do like and subscribe. For more math resources, visit mathinsg.com.